Hey everyone, ready for another deep dive? Today we're going to be looking at symmetry.
Symmetry. Interesting.
Yeah, specifically we'll be focusing on reflection symmetry.
Ah, reflection symmetry. Sounds
Uh-huh.
intriguing.
And get this, our source material is this super cool interactive learning resource. It's from Open Educational Resources, open source physics at Singapore,
Wow.
and they actually use a story about a vain queen
Oh, wow.
and her magic mirror to teach the concept.
That's a creative approach.
I know.
Yeah,
So before we get to the queen and her mirror, maybe we should start with the basics.
Sure, sounds good.
When we say symmetry, what exactly do we mean?
Well, it might seem simple at first, but symmetry is a really powerful idea. It's shaped how we understand the world.
Wow, okay.
The source we're looking at defines symmetry as the property of staying invariant under some action,
Mm.
which I know that sounds a bit technical,
Hmm.
but basically it means something staying the same even when you change its position or its orientation.
Okay, so like a butterfly.
Yes, exactly.
Its wings, they're symmetrical because even if you flip one over, the pattern looks the same.
That's a great example.
So that would be reflection symmetry, right?
Exactly, you got it.
Yeah.
And there are other types of symmetry too, like you've got rotational symmetry. Think of a snowflake.
Oh, yeah.
It looks the same even when you rotate it. Or
Mhm.
like just a simple repeating pattern, like tiles on a floor,
Right, right.
that displays translational symmetry.
Okay, so there's a whole family of symmetries out there.
A whole world.
But for today, we're going to zero in on that reflection symmetry. The kind that our vain queen in the source material is obsessed with. She uses her magic mirror to judge everyone's symmetry. I thought it was really interesting how the source talked about symmetry being like structure and beauty found everywhere in nature.
It really is everywhere,
Yeah.
from like intricate patterns on a seashell to like the arrangement of petals in a flower. Nature just loves symmetry.
Yeah.
And it's not just pretty to look at,
Yeah.
It often serves a functional purpose.
Oh, interesting.
Like, for example, a bird's wings. That's symmetrical shape. Helps it fly efficiently.
Oh, that's cool.
Yeah.
And it's not just nature, right? Humans have been incorporating symmetry into art and architecture for centuries.
Oh, absolutely. For a long time.
The Taj Mahal, that's a classic example.
Yeah, the Taj Mahal is a great one. With its perfectly mirrored design,
Yeah.
it really shows our fascination with symmetry.
Yeah.
And it's not just about grand structures either. Like, look at Leonardo da Vinci's Vitruvian Man.
Right.
It uses symmetry to depict ideal human proportions.
Oh, wow. So it's like symmetry is not just visually appealing, but it also kind of like taps into these deeper ideas about balance and harmony
Yeah,
and maybe even perfection,
absolutely.
which makes me wonder, did Da Vinci's like obsession with symmetry influence other artists and architects?
Oh, 100%. His work had a huge impact on Renaissance art and architecture,
Hmm.
especially the Vitruvian Man. It became this iconic image that represented the ideal human form. You can see echoes of that for centuries after.
Oh, wow.
Yeah.
That's so cool. Speaking of ideal proportions, our source uses that kind of quirky story about a queen who's obsessed with symmetry to kind of like explore this further. She wants to be like the most symmetrical in the kingdom and uses her magic mirror to judge everyone else. So to really get what the queen is looking for, we should define like what reflection symmetry actually means.
Okay, well, imagine folding a piece of paper in half.
Mm.
If the two sides match perfectly when you fold it, that fold line, that's your line of symmetry.
Okay.
Yeah.
So it's like if you held a mirror along that line, one side would be the exact reflection of the other.
You got it. That's it.
Okay.
And, some objects can actually have multiple lines of symmetry, like a square.
Oh,
A
okay.
good square has 4. You can fold it along its vertical axis, horizontal, and both diagonals.
Mm.
And each time the halves will be mirror images.
Gotcha. Okay, I'm starting to see lines of symmetry everywhere now. It's like how a vampire can't see themselves in a mirror because they have no reflection symmetry.
Well, maybe not vampires, but, certain molecules, there's this fascinating concept called chirality,
Oh.
where molecules are actually mirror images of each other, but they can't be superimposed,
What?
like your left and right hand.
Okay.
They've got the same atoms, the same bonds, but they're arranged differently in space.
Wow. So even at the molecular level, reflection symmetry is important.
Absolutely.
This is blowing my mind. All right. But let's get back to our vain queen. The source actually includes this really cool interactive element where, like, you, the listener, can act as a judge just like the queen.
Oh, that's fun.
Yeah.
Like a game. You're presented with these strange symmetrical beings and
Mm.
have to figure out where their lines of symmetry are.
Right.
It's a fun way to test your understanding
Yeah.
and get a feel for how to spot these patterns.
Okay, so let's try one. Imagine this being standing before you.
Hold on, hold on. Let's save the interactive fun for part 2.
Oh, you're right. We'll need to have enough time to really dive into that. But before we move on, I have to ask, why should we even care about symmetry?
Okay.
It's cool and all, but does it have any real world relevance? What's the point of all this besides helping a vain queen, feel superior?
That's the million-dollar question, isn't it?
Mm-hmm.
Honestly, the answer goes way beyond just aesthetics. Symmetry, actually, it plays a crucial role in all sorts of fields, from math and physics to design and engineering.
Wait, really? I guess I never thought about it like that. I always just saw it as a cool visual thing, not something that actually matters.
Oh, it matters, definitely. In physics, for example, symmetry it's deeply connected to the fundamental laws of nature.
Hmm.
Think about the laws of motion, They work the same way whether you're here on Earth or on, a distant planet.
Right.
That's a kind of symmetry.
Okay.
And it allows physicists to, make predictions and develop theories about how the universe works.
So it's like a hidden code that governs the way things behave, regardless of where they are.
Exactly. And there's this fascinating theorem called Noether's theorem, which essentially it states that for every symmetry in a physical system, there's a corresponding conservation law. Like, for example, the symmetry of physical laws over time that's related to the law of conservation of energy.
Okay, my brain is doing backflips trying to wrap itself around that.
It's pretty wild.
But I kind of get it.
Yeah.
It's like symmetry is built into the fabric of reality itself.
That's exactly.
But what about something a little less abstract, like engineering?
Sure.
How does symmetry play a role there?
Imagine you're designing a bridge, right? Symmetry in its design isn't just about making it look pretty. It's crucial for, stability and balance. If the bridge wasn't symmetrical, it'd be way more susceptible to stresses and strains.
Yeah.
And might even, collapse.
That makes sense. So it's like symmetry equals strength. Makes me wonder if our queen from the story, would demand all the bridges in her kingdom to be perfectly symmetrical.
Probably. But even beyond engineering, think about design in general.
Mm-hmm.
Whether it's, a car, a phone, a piece of furniture, symmetry can create a sense of order and harmony, making the object more just visually appealing.
Oh, yeah. I definitely noticed that. Things that are symmetrical just look more, I don't know, balanced and pleasing to the eye. Is that why we're, as humans, so drawn to symmetry? Because it, taps into this sense of order?
Yeah, there's definitely a psychological element to it.
Yeah.
Humans are naturally drawn to symmetry. We find it aesthetically pleasing. We often associate it with beauty, with balance, even perfection. And some studies suggest that our brains might actually be wired to appreciate symmetry. Remember the Vitruvian Man?
Yeah.
That deep-rooted connection to symmetry suggests that our brains might be wired to find balance and proportion aesthetically pleasing.
Maybe because it signals health and strength in nature.
Exactly. It's fascinating, isn't it? And this brings us back to the interactive element from the source.
Oh, yeah.
Ready to put on our judge hats like the queen
Yeah.
and test our understanding of reflection symmetry.
Game on. Let's do it.
All right. Picture this. A strange, blob-like creature with 3 bumps on one side and 4 bumps on the other. Does this creature have any lines of symmetry?
This is tricky. Let's see. If we tried to fold it in half, nope. The bumps wouldn't line up. It seems asymmetrical. Wait, what if it has rotational symmetry?
You're thinking like a true symmetry detective.
Thanks.
That's a great point. But remember, today we're focusing on reflection symmetry, the kind you'd see if you held up a mirror.
Right.
Does the blob have that kind of symmetry?
Good point. Okay, back to reflection. No matter how I try to fold it in my mind, I can't get those bumps to match up. I'm going to say no. This creature doesn't have any lines of reflection symmetry.
You are absolutely correct. That blob, it is definitely asymmetrical, at least when it comes to reflection. And that's a key thing to remember. An object can be symmetrical in one way, but not in another.
So even though it doesn't have reflection symmetry, it could have rotational symmetry.
Precisely. And that's what makes the study of symmetry so interesting. It's not always, straightforward.
Yeah.
And it requires us to, look at things from different perspectives. Just like our vain queen.
Right.
She might discover that someone who's not perfectly symmetrical in one way could still possess other fascinating qualities.
Okay, so we've talked about why symmetry is important. We've played a little symmetry game. but something still feels kind of, I don't know, incomplete.
Mm,
If symmetry is this like fundamental principle that governs so much of the world, what does it mean when things are asymmetrical?
yeah.
Is asymmetry just the absence of symmetry, or is there something more to it? Like, is it just the rebellious cousin, or does it, I don't know, have its own unique beauty, significance? It's a great question, and it really pushes us to think, beyond just our initial assumptions. Because while symmetry might seem like the ideal, asymmetry plays a vital role too.
Mm.
It's often what makes things unique, dynamic, adaptable.
Okay, so, like, where do we see asymmetry making a positive impact?
Let's look at nature again. Think about a spiral galaxy.
Oh, yeah.
It's not symmetrical, in the traditional sense, but there is a dynamic beauty, almost hypnotic to that swirling, asymmetrical shape. And in many cases, asymmetry provides a functional advantage.
You're right. The human heart.
Yeah.
It's not perfectly symmetrical,
Yeah.
but, it's those asymmetrical chambers that allow it to pump blood so effectively.
Exactly. And think about the human brain, too.
Okay.
It's actually divided into two hemispheres, each with like slightly different functions. This asymmetry allows for specialization and complexity in how we think and process information.
Wow, so it's like asymmetry is the key to, like, individuality and adaptability. It's what allows for, like, evolution and innovation.
It's pretty amazing. I'm starting to see it everywhere now.
And that's the beauty of exploring these concepts. They challenge our assumptions, expand our understanding, and make us look at the world with, fresh eyes. Symmetry and asymmetry aren't just abstract ideas. They're woven into the fabric of our reality. They influence everything from the smallest atom to the largest galaxy.
So to recap, symmetry, especially reflection symmetry, it's this incredible principle found like throughout the universe. From the patterns of a snowflake to the laws that govern the cosmos, it's often linked to beauty, balance, and perfection. But we shouldn't overlook the importance of asymmetry, which brings uniqueness, adaptability, and its own kind of beauty.
Beautifully summarized. And this interplay between symmetry and asymmetry, that's what makes the world so fascinating. It's a reminder that there's beauty and importance in both order and chaos, in both the predictable and the unexpected.
I feel like this deep dive is giving me a whole new perspective on, well, everything. I'm going to be looking for symmetry and asymmetry everywhere now. But, before we wrap up, I have to ask, what about our vain queen? What would she think of all this talk about the value of asymmetry?
I think it might challenge her worldview. Maybe she'd realize that true beauty isn't just about, perfect symmetry. It's about embracing the unique qualities that make each individual, each object, each moment special.
I love that. It's like a reminder to celebrate the imperfections, the quirks, the things that make us who we are. So keep exploring the world with that, curious eye and see how symmetry and asymmetry shape everything around you. And until our next deep dive, keep those brains buzzing.